Alright, continuing on here in lesson 2.1 to the next example. Now we're going to look at where the graph is a curve. Okay, so here's the example. Graph the relation represented by x equals y squared plus 1. What I want you to notice about how this is given, first of all, the y is squared and we have the x solved for. Okay? Normally, when you make an xy table in the past, this one we're going to have to make a table for to see what goes on, because it's not a linear graph because we have a variable that's squared. Normally, you always chose values for x. Well, that was usually when it was solved for y. Okay? This one, if you notice, my x is solved for right here. Okay, so what we want to do when we make our table is we want to choose, in this case, because of the way it's given to us, choose values for y because x is alone. That way we can choose some values for y, plug them in, and figure out the x values. So when we make our table here, an xy table, normally you've always picked values for x because we've had y equals something. In this case we have x equals something. So we're going to pick some values for y. Let's try this. -2, -1, 0, 1, and 2. I'm going to pick some positives and some negatives. You in the past have probably done those values a lot for x. Well, now we're going to plug them in for y. So if I plug -2 in for y, I'll just do this first example written out. So I'd have x equals, I'm putting -2 in for y, so I got to square that and adding 1. -2 squared is +4. 4 plus 1 would be 5. So I got a 5 there when I plug -2 in for y. That's what I got for x. Okay? If I plug -1 in, all that's going to change is I'd have -1 right here inside parentheses. So -1 in parentheses squared is 1. 1 plus 1 would be 2. If I plug 0 in, I'd have a 0 in that spot. Okay, so 0 squared is 0 plus 1. That would be 1. If I plug 1 in, now remember, squaring -1 and squaring 1 is the same. You get 1, but then I got to do the add 1 at the end, so I get 2. So these values right here are going to be repeated. A similar thing is going to happen when we plug a y value of 2 in. 2 squared and -2 in parentheses squared are both 4, so 4 plus 1 would be 5. So I kind of have repeated values here also. So let's plot those points. So we have 5, -2, which is right here. We have 2, -1, which would be right here. We have 1, 0, which would be here. We have 2, 1, and we have 5, 2. So here's what this graph kind of looks like. Kind of looks like a sideways parabola, doesn't it? Okay, now you remember, if you have y equals like x squared plus 1, that's a parabola that opens up. Well, what happens when you have x to the first and y to the second here, like we do in this one, okay, it's kind of changes it to a sideways parabola. We're going to find the domain and range. The domain, the set of all x such that what x values are graphed. This will not be all real numbers, because if you think about it, I don't have any x values graphed. That graph doesn't go to an x value smaller than 1. Can you see that 1, the leftmost point in that kind of sideways parabola is 1. Basically, it's everything 1 and above are my x values that are graphed. Okay? Notice from here, so if you're thinking about the domain, everything from here and over are the x values that are graphed. Okay? So the leftmost point that graph ever gets to is an x value of 1. Okay, I'm going to undo that coloring there. So basically, it's the set of all x such that x is greater than or equal to 1. All x values greater than or equal to 1. What's the range? Now, range you got to think about in the y direction, up and down. Now notice the top part of this graph, that would keep going up infinitely. Okay, it never gets straight horizontal. Same thing on the bottom. So Here, really, we're going infinitely up and infinitely down because that parabola, that sideways parabola, would keep getting wider and wider and wider and keep going up and down forever. So that's the set of all y, that it's all real numbers. Okay, so on a line, we had all reals for both the domain and range. Here, we didn't have it for the domain. We only had x values bigger than or equal to 1. Is that a function? Does it pass the vertical line test? No, and I had one earlier like this, but if you draw any vertical line here, we'd have multiple cases, and you only need one. It does not pass the vertical line test because vertical lines go through 2 points. So that would not be a function. Evaluate a function. All right. This is functional notation. You haven't seen a whole lot of this. Okay. Given f of x. This f of x, that's kind of like a y. So kind of think of it what you're used to seeing. It's read f of x. How we read that when it's this is f of x. The function f that has the variable x in it. It's kind of like a y. That's what you want to think of. Okay? This would kind of be like a y also. It's read h of x. So it's the function h that has the variable x in it. Okay? So if I'm doing f of negative 2, okay, I want to look at function f. So f of x is x cubed minus 3. That's the function we're dealing with. So basically this means I want to plug negative 2 into that function for x. I only have the x there where the cube is. So I have negative 2 cubed and then minus 3. So you plug the value in and now it becomes evaluation of order of operations. Well, negative 2 cubed, negative 2 times negative 2 times negative 2 would be negative 8. And then I got to subtract 3, so that would be negative 11. So that would be what we call f of negative 2. Your answer is negative 11, because we plugged negative 2 into the function f. It's going to output a number, okay, because we're plugging a number in. Let's look at b. Now we're doing h of 1.6, so I want to write down function 8, h, which is 0.3x squared minus 3x minus 2.7. And I want to plug 1.6 in for x. So here's what I have. 0.3 times 1.6 squared minus 3 times 1.6 minus 2.7. Okay, and this is where you need calculator. Most of the calculator, I'll pull up the calculator here for you and show you how to plug that in. You can actually, on the graphing calculator and a lot of the newer scientifics, you can plug that whole line in. So let me pull up my calculator and we'll plug it in. So here's what I have. Let's clear that out. I have, show you how you can do this. You're going to plug in 0.3 times 1.6. And I'm going to put that in parentheses. So 1.6 parenthesis squared minus 3 times 1.6 minus and then 2.7. Okay, so notice what I did there. Oops, it should be 2.7. I put 2 7s in. Let's delete that out. And we'll hit enter. And it's negative 6.732. So the calculator basically followed order of operations. And I would consider that showing your work as long as you showed me plugging it in. So we got negative 6.732. That would be what we call h of 1.6. Okay? Now, for those first two, we were just plugging in a number. Notice what's different about this one. Right here. We're doing f of 2t. Now I'm plugging in not just a 2, a 2t. So every place in f of x. So here's f of x. Let's write it down. X cubed minus 3. So now I want to do f of 2t. That means I want to plug 2t in every place I see an x in the function. So here's what I have. Here's my x. Now 2t has both a number and a variable. So we've got to put that in parentheses. And that x was cubed. So I got to go 2t in parentheses cubed. And then I have the subtract 3 at the end. Okay, now what's 2t cubed? A couple different ways you can do this. You cube both the number and the variable, or it's t to the first to an outside power of 3. 2 cubed, though, we actually have to do, so it's 8t cubed. The other way you could think of it is 2t times 2t times 2t. Cubing it means to multiply it by itself 3 times, well, that would be 8t cubed. So a couple different ways you can think about it. And then we carry down the minus 3. So I end up with an answer with 2 terms here. Now the only thing you got to check here is, are either of them like terms? Possibly you could end up with some like terms. There are no like terms. I don't have anything to stick in for t, so that is my answer. I just get an expression. So when you're finding or evaluating a function and you're putting in a variable for another variable, you're going to end up with an expression that's got that variable in it. But you just combine like terms, go through and simplify the expression. Okay, so I want you to pay attention to this example over here at the end, and I know this isn't in your guided note packet. If you had this was the given function, and if I said find f of triangle, well, notice what it is. Every place we see an x, we're going to plug a triangle in. So it'd be triangle squared minus 3 times triangle, and we showed parentheses to show multiplication there, plus 2. You can't simplify any further than that. That would be your answer. If I said, just to give you another example, let's use our g of x up there. So let's say g of x, no, not g of x, let's use f of x. If f of x was this, we'll use the one from the previous problem. And I said find f of square. Well, then I plug a square in. So it would be square cubed minus 3. I mean, you could just write it as square cubed minus 3. The important thing is, whatever's in there is what you have to plug in. Okay, so I gave you an example with a triangle, and you might see something like that. I might assess you on that on a quiz or a test, so be prepared. And you can't go any further than that than plugging it in. Like here or here, that would be your answer. You can't go any further.